Thanks for coming to my talk. I realize it's in the sponsor track, so maybe that seems less desirable. However, I'll try not to be too sponsory. You know, people are always telling me not to give a vendor pitch, which is exciting because now I can give you a slight vendor pitch. But I'll try to follow my rule of vendor pitches, which is usually what they mean is don't be boring and give a bad pitch. But to that end, what I want to go over is, as my lengthy title goes over here, is I've worked in the infrastructure space for quite some time, and I was a developer some time ago, and I've been following for various reasons what's happening with this wacky Kubernetes thing for quite some time. And I've always been curious about, you know, what application developers, what developers are supposed to do about it. Because when it comes to system developers, there's plenty to do for them. They're very excited about it, and things are juicy and thrilling for them. So what I'm going to go over is a little bit of what my investigation, if you will, has been in looking at this space. And it's, you know, I'll be honest, it's a little bit of a first pass at it. I'm sure there's some more details I'll find here and there, and probably some things I'll get wrong. But with all development, we'll just, you know, recompile the code and redeploy it, and it'll be as if it never happened. We'll have a blameless postmortem, and everyone will be very happy about things that occurred, and will have grown and gotten to collaborate with people. So to that end, when I have followed Kubernetes over the years, I mean, this is just a sampling of some of the more famous quotes about Kubernetes. But the impression, I think, as a developer that you get is this very paradoxical thing. So I was an industry analyst for a while, so I also kind of follow industry trends. And I started out at a little place called Red Monk that was very into basically studying how developers and other people at the bottom, if you will, help spread trends. And they do all sorts of other things like in that area. But the paradoxical thing that's happened with Kubernetes over a while, and I'm not sure if this is true, but it sure feels true, is that the reason it's popular, there's probably a couple of reasons. One, because Google did it, and their stuff must be awesome, and people pay attention to it. But two, developers have always been very, very interested in Kubernetes. They've always been wanting to use it. They've always wanted to put it in their system, and it finally has peaked in the past few or so years, and it's become a de facto standard. Which is to say, there's a whole lot more deployments that need to happen, especially in large enterprises. But if you were to ask people, they would probably say like, oh yeah, you should be you know, deploying on Kubernetes and using that. Now, despite that, when you go talk with the Kubernetes and containers thought lords and ladies, the first thing they're going to tell you is developers should not care about Kubernetes. These people who have kind of brought us to the party, let's get them separated out and not really worry and have them worry about the intricacies of Kubernetes and what they should be doing. And I don't know what, you know, people like this think they should focus on, but let's refocus them on something else. And in fact, even to the fact it's gotten to the point where one of my fellow VMware colleagues, you know, likes to say that he's ready for Kubernetes to be boring, which I don't know. Developers rarely find anything boring, which is probably why they're interested in this new thing and have helped spread it. So, you know, kind of in response to this, what I've been interested in is like, so what should developers do if they feel compelled to explore Kubernetes? And like any good little analyst, what I like to do is start off with some more fundamental questions, like what should a developer be doing? Why do they exist? How do they get funds for their fancy toe socks and the deodorizers that necessarily go with them? Although I would imagine those are designed to actually be breathable or whatever. Anyhow, I want to start off with a little bit of like, what is the point of a developer? Why would they be interested in any technology? And I think, to put it in a jokey way that one of my enterprise architects here in London put it once, the point of an application developer, right, is essentially, now there's some exceptions here depending on exactly how you create an interface for things, but basically, you know, you've done your job if you're moving pixels around on the screen, right? Like, if you're doing something and pixels aren't moving on the screen, maybe you're shoring up things or refactoring them or doing whatever sorts of things you are, but the ultimate goal is eventually you'd like to move pixels on the screen, right? You have a user, hopefully a person who's using your piece of software. They're going to be clicking on something, accomplishing some task, renewing a passport, paying a bill, whatever it may be. But eventually you're getting to the point where you're thinking, so they need to accomplish some task, and I'll go over a little one here briefly, but how, as a developer, can I write some software that will change the UI, that'll add new features in, that essentially moves pixels on the screen and solves some problem for them. And there's an even fancier way of talking about this that we're always trying to push people towards nowadays, which is thinking about product. So instead of thinking about a project where you deliver a whole bunch of requirements, I mean, everyone knows the story of waterfall and why it's bad. So when you go back to doing that to your normal jobs, you can feel a little sad, I guess, if you have to do waterfall things. But we all kind of understand the idea that we should be developing a product that's evolving and paying attention to the best way of implementing things. Like I was just talking with someone from Norway who was very happy about re-implementing the way that you would register your car. And they moved it from a COBOL system and moved the pixels around on the screen in such a way that it was a much more efficient way of registering the cars that they had, which is a great example of just making people's lives better with software. Now, I want to suggest that the second thing to that end that a developer should focus on is removing as much waste from the system as possible so that they can focus on number one, right? And again, this gets to the thing where like maybe you're not moving pixels around on the screen or paying attention to your end user, but you're thinking about the tool, the whole, as we would call it, software supply chain, and making it as efficient as possible so you can focus on actual features in your application. And by waste, this is a term that came about in the mid-2000s or so when lean manufacturing ideas were picked up and made into lean software, and later on picked up by DevOps people who brought in the idea of a bottleneck. But the idea is if I'm waiting around for something to happen, if I'm spending time configuring something, if I'm doing anything other than thinking about how am I solving the user's problem, that's probably waste, right? If I'm doing some activity and the end user of this activity doesn't really see immediate value in it, and you have to kind of explain why updating the JVM is extremely valuable to someone who wants to pay their bills online, then that's probably a certain amount of waste that you need to figure out taking care of. So the reason I think it's important as the number two thing for developers to focus on of removing waste is because to focus on number one, I think there's this model or approach they have of figuring out the best way to apply features. And this goes by all sorts of names. I just think of it as a small batch loop or small batch process, but there's all sorts of ways of going through this. And I'll show an example after this, but essentially, when you're trying to improve the life of your user, and maybe it's not the life, you're trying to help them accomplish a task as efficiently as possible, or as efficiently as they want to. You come up with a theory of how you might do that, and as a developer, you basically write code. That's usually what you do. I guess it could be argued that in order to make their life better, you would eliminate code, but let's kind of leave that side case over here. But you write some new code that gets exposed as a feature, and you want to, the user is going to interact with it. So going through this loop, and hopefully you do it on a weekly or every couple of weeks basis so that you get enough feedback so, as we'll see, you can actually change things. But you come up with a theory. If I move these pixels around this way, the user will accomplish X task better. How would I measure that? So you come up with a way of how you would test that. So a very simple one is like, we'll sell more stuff, or it'll take a shorter amount of time to renew a passport, right? Like you come up with something you would actually measure rather than just make up something at the end to figure out if you've done a good job. So you introduce some discipline there. And of course, it's very important when doing an experiment to actually do the experiment, which is to say you deploy the code into production, you observe people using it, and if you've done a good job, then you move on to solving a new problem. And if you didn't deliver on your theory, then you go through the loop again and try another way of doing it. And so I see this pattern used over and over again on a weekly, if not sub-weekly basis, to scope down little experiments and very quickly get to the point where you're gathering feedback about the quality of your assumptions, about the quality of the features that you've put into your code, and you're constantly improving the software. And then hopefully at some point also improving the way your organization conducts whatever it may do, business or governmental type of things. So as a quick example of this, this is an example from Daimler. Most people think of Daimler as Mercedes, but they have there's a team there that follows this small batch loop and a lot of the things that I'll be talking about. And their unit head, Sophie, told me this story of what they do in this unit is they basically have the web front end for if you're interested in buying a car, a Mercedes car, you go there and you search around for what you want and you customize the car. And she was telling me a funny little side note that not everyone, but most people build out like the ultimate crazy tricked out car. And they're just having fun, and then they go buy their nice suitable station wagon to haul everyone around. But they like to start with a crazy car there. But one of the things they noticed in the searches people were doing for cars, right? And this is the first thing of having this product mindset, is the development team thought to think, what are people searching for? Let's go analyze what they're searching for so that maybe we can improve this process that they're going through. But something interesting they noticed is that a lot of the searches, a significant amount of them, were for vans, for these Mercedes Sprinter vans. And sadly, when people would search for these vans, very little if no search results would come up. Because on the business side, over in Daimler, the car business unit is a different business unit than the van business unit. So naturally, the search engine you would have would not integrate these two things together, right? Like, why would someone searching for a car ever want to, get an ice cream truck as something that they want to do? But in observing this, the team came up with a theory that, well, maybe these people, if there's people searching for vans, maybe they'd like to, buy a van from us. And so what they did is they went back to this van business unit, and they made the case that what we should do is integrate our two systems together, which probably was a lovely task to kind of go to a whole different business unit and integrate with their backend system. And let's surface those results in the UI and see what happens. Our theory is people will actually be interested in buying these vans, and it will result in essentially new revenue around it. So they did that, and lo and behold, you can probably guess the answer, people were actually very interested in buying these vans, because it turns out that there's many, many people who aren't necessarily plumbers or ice cream vendors, and they want to customize the vans and make them into campers and things like that. So there's actually a significant amount of interest in these professional vans that heretofore had not been surfaced in kind of the commercial mindset. So I like this example. One, because it's a customer of VMware's, but also because it shows this curiosity that comes with this product mindset that developers have and how they can apply this theoretic loop, this loop of theory. But I think really it also results in the ultimate thing that I would hope most development teams are focusing on, and that is improving the way that their business operates or whatever the organization they're working in, right? So what this results in is a bunch of essentially very cheap, if not free revenue for the company that was just kind of lying there on the table, and the developers were directly responsible for thinking of that. So how do you get to the point where you can apply that loop? And then we'll get into the fun Kubernetes stuff in just after this. When over the years, especially if you go back and look at the original kind of DevOps and even lean stuff, there's a simple tool that's existed for a long time, kind of a mental tool of removing waste, and that is to look at an entire end-to-end process of producing something. Now, way back when, Damon Edwards and Willis called this I think they called it aha to kaching, but I like alliteration, if that's the right word, so I call it the concept to kaching. And that is, if you have an idea, you want to track every single process that happens to actually having an end user use that, right? Not only like writing up a backlog and coding it and sticking it in a container, but the idea, even going through selecting doing something and going through running it and managing it and deploying it and going through the cycle of updating things. So you try to widen the scope as much as possible on the full end-to-end process that you have. And you can think of this as it's a pipeline, sort of a subset of this, but a pipeline or a supply chain or your idea tunnel, I don't know, whatever you want to call it, but it's that, or a value stream if you want to use lean terminology. But when I look at organizations that are removing waste, this is the perspective that they start with, right? They don't start with one little individual thing. They look at everything as the responsibility of the developer team, of the product team, if not to liaise very closely with people. So figuring out how you remove wait times, tickets, and passing off to other people and things like that from this entire process is key to getting to focusing on that number one thing, moving pixels on the screen. Now, the reason why something like Kubernetes and other platforms like Cloud Foundry become important, you start to pull away on all these things that are clogging up the system. And even beyond the developers building things, right, getting them containerized and integrated, you get into the continuous delivery point where your expectation is not only do we expect to deploy to production on a weekly basis, but multiple times a day we want to stand up a new environment, a fresh environment that we have, and just deploy our little code into it. and kind of test the incremental changes that we're making, right? That cycle that a developer goes through, there can be a tremendous amount of waste in that, depending on the platform that you have. But this is a distressing thing that I've tracked over many years, and there's, you can't click on it now, but you can go look up the slides. I have them on my Twitter account at COTE if you want to link to them. But anyways, over the years, my kind of general sense is that never minding continuous delivery, where you're committing some code and then it gets deployed to production, just looking at continuous integration, there's only about 30 or 40% of people who actually do that, right, in their organization. And this is very distressing, because obviously if you don't have that, that's your first bottleneck, right? So until you actually solve this problem of continuous integration, you won't be able to get to the point where you can do continuous delivery, where you can even worry about delivering to a platform like Kubernetes or something like that. And I think this results in what you see over and over again, that many large organizations aren't actually deploying very frequently, a couple times or maybe once every quarter or so at best. So I want to ease into thinking about cloud-native platforms and things like Kubernetes with this theory that I have. It's fun because I get to use the word governance, which amongst developers is a terrible word. I appreciate everyone staying here after I said the word. But my theory from talking with large organizations for a while is that there's something positive you can do with governance if you think of it as a sort of living thing that you implement and actually automate and pay attention to, not just, I don't know, some wiki pages or some pages on Confluence that no one ever wants to go look at. Did I get that reference right? Confluence, right? That's what people use? Okay, good. All right. I actually just make PowerPoint nowadays. I haven't developed in a long time. So what I observe is that the sort of a lot of waste in the system comes from variation, non-standard ways of doing things, and basically relying on development teams to self-apply governance, which is a bit like asking my son, if I sleep in when it's time to go to school, and I ask my son and daughter to put their shoes on time, get themselves dressed, and get to school on time so that the Dutch government doesn't fine me however many €100, right? People don't really govern themselves without a lot of oversight. But more importantly, they'll decide to use tools outside of what the bounds of governance are because they think that they're more awesome. Anyways, what I've observed over the years is that used correctly, or correctly is the wrong word, but used kind of cleverly, if you have a platform and a set of build tools, an overall way, a supply chain of putting software out the door, you can actually get very far in applying governance and using applied governance as a way to remove waste from the system and get beyond that deploying once or twice a year, once a quarter sort of thing, because you're removing so much waste for the system. So that's what I want to look at next, is how developers can think about using a platform as a type of implementation of governance so that they can remove waste from the system and start to deploy more frequently. And then also, to use another crazy word that people tend to run away from, how enterprise architects can change what they should be doing to also help out to build this platform of governance to remove waste from the system, to get to the point where you're selling vans to people who want to make them into four-wheelers. So we'll start with developers, which is really just an excuse to use this cool clip art that I found one day. So let's look at Kubernetes. Let's use Kubernetes as an example of a platform of governance. And first, there's a lot of sessions, probably even here, that you can go to that will give you a deep dive into what Kubernetes is and how it all fits together. There's probably also lots of sessions that will tell that you as developers should not actually be in the session listening to it because this is not for you, and then they'll go on and on about it, which is always enjoyable. Anyhow, so I'm going to give a very brief summary of what it is, which is not going to be very helpful for you, and then some references for if you want to dig into it. But the most important thing to think about with Kubernetes is it's basically a system that takes a containerized application, divided up into all sorts of containers, and figures out how to place those containers across VMs or nodes or worker nodes or what have you, and also figures out what configuration state each of those containers should have, and how, when those containers go bad, when they get in a funky state, how to restart not them, but how to start new containers that will make the overall system healthy, how to do all the network configuration and management so all your different containers can talk with each other, how to apply various security concerns, how to scale up and scale down, how to do all that exciting operations stuff that the DevOps world has been really trying to kind of bring to the developer world for quite some time. How to handle logs and observability and things like that. And I think what's key to this when you start thinking about things as a developer is, well, one, it's nice to have one of these, right? So like maybe you've tried to set up a cluster on your own, right? So setting up a cloud, if you will, is quite the task to go through, and something that many people probably have fun doing if they're a developer. But having one of these instances running that's kind of shared in your organization and used in your organization is a huge point of governance that often a centralized team, maybe even enterprise architect types or infrastructure people, are starting to think about, right? Like, how do we provide this as a service, or provide ways, kind of recommendation for people to go out into the various cloud providers to use what they have. And really, the advantages of running things in this way, to really reduce it down and then kind of go over some of the details. I think for my purposes, and I think for purposes of developers, there's a couple of things that are very advantageous. One is you're using containers, which is like great because they're very efficient. It's kind of like a logical unit of dividing things up, and it's a very fast way of doing development, as we've seen over the years. But two, and this is the point of governance that comes in, is there's a very standardized way of packaging up your applications and describing how they talk with each other, and a very standardized life cycle of how release management is done and how you basically model out the system architecture. Now, if your first thought of a developer is like my son's going to be a lawyer one day because I'll tell him some dictum that I have, and he'll instantly find the exception of like, what's the loophole for it? He's very good at that. Hopefully, my daughter's a little younger. I'm sure she's going to torment me with that soon. But as a developer, obviously, you can subvert any system pretty much, and you can think of a terrible way to use it to not use those standard things. But when you look through the structure of Kubernetes, there's a very, very standardized way of basically how is everything done outside the boundary of your container. So you don't have to make that up and think about how you would package things, how you coordinate things. And it also means, another great benefit is it means your operations people will probably know how to manage your stuff, right? Like, instead of it being some strange, Baroque, strange to them, sort of like lovely to you, but some unique, strange, Baroque application that's bundled up and describes how it needs to do networking and storage, there's this one standardized way that they think about things. And so it's a lot easier for other people to come in and manage and help you with that application and build the platform that you need from it. So there's a lot of operational benefits that you get from just kind of being a container system. And also you introduce this standardized way of doing things, which removes waste, right? Like, you don't have to worry about that. And it removes the waste of people helping you manage that. So now there's a few consequences. If you're familiar with or remember the idea of leaky abstractions, right? Like, I think infrastructure is one of the first upward leaky abstractions, right? Like, the infrastructure that you run your software on tends to have some pretty consequential impacts and requirements for the software running on it. No matter what it might say about you can be ignorant in layers of abstraction. But there's a few things to focus on. One, you're going to be essentially, again, you can always subvert this stuff, but you'll be developing a distributed application, right? So each of these containers is going to be some component that coordinates with other components, that has to figure out how to find the other components over service discovery, how to make sure it's doing all of the great circuit breakers and load balancing and checking security, doing all of these things that are required in a distributed system. And if you saw right next door Denise's talk earlier, where she went over the why distributed systems are painful, that's a great overview of what it means to think as a developer about doing distributed system development. And there's lots of great cat pictures in there as well that she drew. But again, the other thing is, of course, you're doing things in containers, right? So you're building up containers and dividing your application into that. And so in summary, it's microservices, right? And I don't necessarily, for the purposes of this, care so much about, let's call it the cultural stuff of microservices, of like, we've got all these teams that are independently operating and they sort of come together and everything works out well, which I think is a great goal. But I would just start with like the technical aspects of microservices and not worry about the organizational aspects, which hopefully will follow if you get that set up. So there's a couple more things to plan for if you're going to be running on something like Kubernetes or other cloud foundries, even some other platforms you might have. And that is, if you think about the baseline of what Kubernetes provides you, right? Like, you as a developer have to give it a container. Now, what goes in that container? It doesn't care, right? Like to use a phrase from one of my friends, Paul, you can put any garbage you want in a container, which hopefully you won't do. But if you don't want to put garbage in your container, what that means is you have responsibility for what's in that container, right? The operating system, the frameworks that you use, cutting back things, hooking things together, accessing files, making sure your JVM version is container aware or configured correctly. So there's all sorts of things that come up with worrying about managing your own container, right? And there's a couple of great talks, if you're in the Java world, going over your Java concerns and ways of tuning things. But what I've observed and what I would recommend is don't do that, basically, right? Like get yourself a tool. There's all sorts of tools available. There's a few referenced down there. But get a tool that worries about managing the container for you, right? Like a very classic thing to worry about is like, well, what if you have to upgrade the operating system? Right? Like patch that across all the containers and the versions running that you have. This can be a hassle to deal with. And again, go back to what waste is, right? Like me, someone who wants to renew my passport, which is something I had to do recently, obviously, like I don't care about patching your operating system, right? Like I want to update my passport and not have to wait in like a 30-minute line at the US Embassy. Like I just want to be able to do that. And so think about how you can remove these things of waste, like worrying about your operating system or configuring what things look like and making sure you get configuration passed down in there. So another thing that you'll hear about a lot in the Kubernetes world, and I've even sort of violated this vocabulary several times already, is Kubernetes doesn't actually think necessarily in terms of containers. Now it certainly does, but the unit of concern is instead a pod, like a pod of fish things. I guess they're not fish unless you're Herman Melville. They're mammals who float around. But anyways, the pod is one or more containers that are related to each other somehow, right? And the reason I go over this is, well, one, in this book, there's a great sort of rule of thumb for how you divide pods up. But you'll be thinking in terms of pods that you're putting in your manifests and your deployments and things like that. And it's important to think about how I decide what containers go in there. And there's a good rule of thumb, which is generally, if these are two components, two processes that would be running, and if they were on a different server, they should probably be in one pod, right? Because the characteristics of a pod are that those are the things that are scaled and descaled together. It's, again, that unit of compute that Kubernetes thinks about. So classically, as another example, databases tend to be in their own pod, if you will. They don't tend to be deployed with your front-end layers or other layers like that. They're managed separately, and they're managed in different ways than your application code. So the most thrilling, joke-bearing part of Kubernetes is all the YAML. Now, you can also put things in JSON, which no one ever talks about. So if you want to be a real maverick, you could do all this in JSON as well. That probably would be a good Medium post if you're into that, how I learned to love JSON in Kubernetes. But you need to start becoming aware as a developer of how things are packaged up and represented, right? How we take the containers. We say that this pod that we have, I want these container images in it. As I'll get into, this is the way you can check on the health and scale each of these containers. This is how I group them into a pod. This is the networking configuration, essentially, that I want. Here are load balancers that I want you to have. But there starts to be some more interesting things as well of how do I come up with a release plan? How do I want this deployment, this application that I'm describing released? Do I want to do a rolling upgrade of it? Do I want to do a staged release of it? Do I want to do A/B testing, so I'm going to do multiple versions running at the same time? But you, as thinking about that whole end-to-end cycle, if you care to take on a lot of this, you start to think about the life of my application in production. And that gets described quite a bit in these files. Now, there's a few other things that are in here as well, having to do with configuration and something called selectors and annotations and things like that, which are a little more intermediary. But you'll spend a lot of time playing around with this YAML stuff. And especially for larger deployments and including other frameworks, things can get a little crazy quickly. So it seems like what people like to use the most nowadays is this other component or project called Helm, which basically is a it manages multiple manifests and deployments for you, targeting it as, here's a reusable component that I want to bring into Kubernetes, and I want to have it interact with my applications over here. So it's kind of a YAML for your YAML, essentially, or JSON for your JSON, which people tend to like. So just to give you a little zoom in there, and this is from someone playing around with the Spring Music Store, you can kind of get a sense of, like, at the container level, here's some of the things that you're telling Kubernetes about in your deployment file here, right? And you can start to see some of the interesting things that are in here, like the probes that you'll be using to do health checks, and some of the other aspects that are in there, the container that you'll be pulling from a registry, the image you'll be pulling from a registry. But it's a fun, exciting world of configuration. And then very, very rudimentary, right? Another thing that's important to pay attention to are the life cycle the life cycle hooks, if you will. And this is my terminology for it, but the way I would think about it. And there's a few of them that are actual things that you will very much so want to do if you're sticking your applications in probes. That is, putting them in containers that are put into pods. And most of them have to do with the life cycle of bringing up that pod and the containers in it, checking on if it's healthy, and if it's not healthy, it gets destroyed, and then restarting a brand new one, right? So very familiar things if you've done any programming, that you have these stages. And so if you remember back to here, right, like, let's see if I can find it. Right here is like, this is an example, right? You're mapping that what's going to happen here is this is using Spring Boot. So what it's doing is there's a web server running inside the container that Kubernetes knows how to call, which is exciting. And so what happens is you're mapping, everyone calls it a health check nowadays, but the liveliness probe. And so you're responsible for implementing when this request comes into the container, you need to respond with like, yes, I'm cool, please don't kill me. Right, that everything's fine. And there's similar sort of things that you have as far as readiness, right? Like, you've been booted up and you're ready to be used, so now I can start directing traffic to you. There's also the startup one, that when things get started, like, initiate your boot sequence. And then there's a few other procedural things that are over here. You know, after it gets started, the post start gets called, and so forth and so on. And then another area to be aware of is that when you're doing logging, you just log out to standard out and standard error. These are all very basic things that a quick overview of Kubernetes will give you. But they're things to start thinking about. When I move this application over, these are things that I must implement if I want to be managed by it. Now, there's a whole lot of other stuff, and that should be externalized, not spell-checked, internalized configuration. Although I guess eventually you have to internalize the configuration, even if it's been externalized, if you never set any of the configuration that it really exists. But there's all sorts of other things that you should be aware of, or at least get a friendly ops person to help you out with, right? Setting up the type of storage that you want, figuring out the multiple types of load balancers that you would want to go through. And I think the most pertinent thing for developers is worrying about how you get your configuration right. So unlike what it's typed there, there's a concept of externalized configuration, and where configuration gets stored instead of shipped with your container, which all the Kubernetes developers make a very big deal out of this externalized configuration thing. But I think up in the application development layer, we're pretty familiar with this concept, if only from Spring, of just injecting configuration into what we have. But that's kind of taken up to the system level. So as said, that was a very shallow, not too comprehensive overview of Kubernetes. There's a couple of references here. I think the new edition of Kubernetes up and running is a good broad overview of things. And I think this is kind of like a philosophic treatise over here on the idea of cloud native. It's a little more high level and things like that. And then over at VMware, we have a whole bunch of free coursework you can go through. And then, of course, we have Spring Cloud Kubernetes, which is a way of wrapping around a lot of those fiddly things that you might be worrying about. So let me close out by looking at enterprise architects and how they should be involved in Kubernetes, how they can take advantage of it to make their organization better and, in theory, make their job better. I think it would make them happier personally, but make the execution of their job better. And again, going back, kind of back up the stack, right? Like my theory is that putting these kind of platforms in place, they introduce several, to use another phrase, control points or points of governance that someone like an enterprise architect could have to remove waste through the system by standardizing on things. And I'll get to, what happens when that waste removal goes stale and it's really old technology that no one wants to use in a little bit. But what I've observed over the past several years and what I see amongst the customers that have worked with Pivotal and now VMware is most of these organizations, I mean, if you think about what Kubernetes is, right, like it's a stack It's a platform that you have. And having gone over just a little bit of what developers would need to do to run on top of Kubernetes, you can think about how you would introduce various frameworks on the build side to build up the containers that you have, right? To make sure that you put patches in them, to make sure that you're following policy of how you do networking. And then you would have other frameworks for, like, if we want to do a sort of service mesh in there, we're going to need a whole host of ways of standardizing on how things talk with each other and how errors are handled and how we have enough instrumentation and observability and tracing so we can troubleshoot things once they're in production. And then we're also going to have way up the stack, we're going to have frameworks for doing just the common, whether it's streaming or doing reactive or however it is you want to architect your application. So these stacks, whether you plan for them or not, they get built, right? And more often than not, there are many of these stacks in production, right? And they've been built over usually the decades. And the enterprise architect is sort of always scurrying around to make sure that these stacks are not only, well, I don't know if they do this, they should. Not only that these stacks are operating well, but that people are actually using the stacks in the way intended, right? That they're following the governance. Now, a lot of the organizations we work with, not only do they standardize the infrastructure part, but they use one of the things we have called Cloud Foundry to have a very developer-friendly way of interacting with it, packaging up their applications, making it a self-service deployment way of having development teams run on top of that stack. And they tend to centralize as much as possible, slowly over years, onto having their applications on this one stack, so that they can enforce that governance and remove as much waste as possible. Now, if you're like I was, when I was a young, excited developer who never got a haircut, your first thought is that sounds terrible. Basically, I'm going to be using an ESB for the next 15 years. Because that was the stack that the enterprise architect introduced a while ago, and it never evolves and changes. And so, one, I might try to find a new job because developing on this technology is awful, or I'm always going to be trying to figure out ways of subverting that governance and not working on that stack. And this brings into, and these are some, if you saw Denise's talk, this is one of her drawings, so you could expect more of that if you saw the recording of her talk. But this is a pattern, if you will, a large pattern organizationally that I've seen organizations, it's sort of what they have to use if they want to standardize on a platform. And that is, instead of thinking about, as one person put it to me, using enterprise architecture as a policing function, so they go around and make sure you're following their governance and you're using their platform. Instead, they think of it, again, to be alliterative or whatever, they think of it more of a partnering function or a product function. And that is this group down here that's running your platform, that stack that you have. The first realization they have is that we have customers, and those customers are developers. And so anytime you have a customer, it's always good to check in with your customer and see if they're happy, which for many sort of EA groups might be a slight epiphany. Definitely operations people when I've talked with them. And so what they end up doing is, if you think back to that small batch loop, right, that product loop where you're constantly product managing the features that you're putting out to your customers, the platform team, the EA team, whoever's building that platform, they look at those developers as their customers, and they look at the platform as the product that they're delivering. So they're constantly trying to come up with their own theory of how would this be better, what features can we add to it, what new functionality can we add, which I know sounds a little bonkers, but there are many large organizations that I've talked with who actually do this, who actually have a product manager in usually the operations area who's thinking about how we're building and developing this platform. And it starts to get very close to site reliability engineering and that kind of programming SRE thing that you might have come across. So this is the way that hopefully you ensure that developers actually want to use your platform and that your platform actually evolves over time and doesn't stagnate. Now, the second, maybe even more important thing that I think, especially if you're thinking about Kubernetes or any sort of cloud native thing or any transition or any transformation, hopefully not analog, but analog or digital, is thinking about how you're worrying about modernization. Now, what do we mean by modernization? That's actually a good question. Essentially what we mean is you have some old applications, some old code or systems or services that are no longer providing whatever function they need to. They might also be too expensive, but you can't, for example, one thing that comes up all the time is we want to have a, I forget what they call this, the unified customer view. So we've got all these different views of a customer, and we want just one sort of call somewhere that will give us this one view of everything related to the customer, which is a great sort of experimental probe to do on your gigantic enterprise architecture to see how long it would take you to actually do that. But in doing something like that, or if you saw Sam Newman's talk about breaking up a monolith earlier, right? He kept using an example of an invoice, right? An invoice is spread all over here. But if it takes too long to find and work on an invoice, or if it takes too long to get this unified customer view, you probably have a bunch of services that are hidden behind a ticket desk somewhere, or just like you have no idea who like is in charge of putting changes in that anymore. So you need to modernize it. And also maybe you're bored and you just want to rewrite something, which if that's what you want to do, I won't tell anyone. It's cool if you want to entertain yourself by rewriting stuff. But usually in a large enterprise, I think this is like the #1 thing that prevents large enterprises from innovating, from evolving their software. Because after like decades of all sorts of systems building up, like I was talking with some people from Air France KLM, and they still have a system from 1968 running on a custom-written operating system that's part of the core like booking experience. So I fly on KLM all the time since I live in Amsterdam. So I guess my life has been supported by COBOL multiple times in the past year and a half, which is kind of fun. But anyways, you've got decades and decades worth of software that works, right? But then also something that I think a lot of us tech people miss out on is like, well, we definitely miss out on profiting from it. But we miss out on far of noticing is all of the mergers and acquisitions, the M&A that has happened. So if you think about one gigantic enterprise with all of its legacy, and then you acquire or merge with another, now you have 2. And then you go buy another one, and now you have 3. And then you have a financial crisis, and you amalgamate all the banks together, and now you have 10, right? Like, you have these huge systems scurrying around. So anyways, not having a program that's actively modernizing these things is eventually going to slow down your system to a halt, and you're not going to be able to move pixels on the screen. Like, your chief marketing officer will probably be able to do their promotional stuff and hire some agency to do something, but it's not really going to come back to your core system and improve the business. Like, think all the way back to the wanting to put van search results in a car search result, right? Like, that is you need to make sure that you can actually interact with that system and modernize it. So in doing that, right, and I think this is pertinent on its own, but it's especially pertinent if you're thinking about a cloud-native platform like Cloud Foundry or Kubernetes or Cloud Foundry running on Kubernetes or whatever. You're going to be moving applications over there, right? And so what you would like to do is I would advise that what you would like to do is make sure that you're not just moving, you're not just lift and shifting stuff over there. Like, there's a fun phrase that like, your mess for less, but I guess in the case of Kubernetes, it might be like, your mess in containers. So instead of just moving things over there, it's important to put in place a pretty rigorous program of modernization. Now, we've helped a lot of customers over the years do this, and so there's some practices that have emerged from that work and some cookbooks. But there's some general characteristics that it follows, and one of them is the first thing I like to tell people is it's going to take a long time, right? So you can't expect that you're going to do things. Nothing really happens overnight, but you can't expect that you're going to do everything in like 6 to 12 months, right? So as an example, with Air France KLM, they have like over 2,500 applications. And I forget the exact number of years, but they're thinking in terms of like, 3-5 years or so that they would be able to convert all of these things. There's a Dutch bank that we work with, and in the first year or so, they converted over about 180, 200 applications over to a new way of doing things, but there's many more to convert over. So you want to start with that one important thing, right? Set expectations about how long it's going to take. Instead of being quick. Because the best way to kill some positive initiative is to fail at it because you set expectations wrong, and then there's no reason to improve, and then you're right back at the beginning. The other thing that people recommend often is if you think back to that small batch process, right? It's a very iterative learning process where you set up a theory of how you think something should work, you do the experiment, you observe if it worked that way, and you modify your assumptions based on that. And so you see this over and over again with portfolio modernization, that we start with a small amount of applications. We come up with metrics of what success would look like. We kind of figure out what would a good and a bad look like. You actually do the project, and you update your procedures and the way that you're managing your portfolio accordingly, right? So you go through that process, and you end up starting to build out a cookbook of what are common patterns that we do things that you can share more broadly. And we have a little cookbook that organizations often start with, kind of a starter dough, if you will, and then it's kind of mixing metaphors, but in the same domain. And then they kind of grow and add on their own layers of doing things. But the important part, especially for enterprise architects, is to really take this modernization task seriously and to put a very disciplined, actually doing work sort of process in there where you're modernizing things at a pretty steady clip. And I think the other snarky way of putting it is like, ultimately making sure that your enterprise estate, your architecture was agile and malleable enough and running efficiently such that your company could evolve in the future and add new features and didn't have to wait is kind of sort of what the job of the enterprise architect was in the first place. So if you're beset with having to modernize something, the enterprise architect should maybe be reminded of what they should be doing in the first place. Someone was UMLing on the job instead of implementing things. So I'm going to skip over this part. There's all sorts of patterns, and I think Sam's talk went over all sorts of great ways. This is just one thing of deconstructing monoliths and a very disciplined process of going through it. But there are very well-known patterns out there for following this. And as always, when it comes to engineering things, there's two critical things. One is follow the process. And then two is actually do it, right? Like I find a lot of improvements and a lot of sort of ways people get better is it doesn't necessarily always matter what sort of agile development process or what kind of design process or loop they're following. But it turns out they weren't actually doing very much from the get-go. So they just start doing something, and it's better than the chaos that they were doing previously. So going through that work has all sorts of technical and actual business improvements, right? So going through putting in place a modernization practice, thinking through how you might build a platform for yourself, worrying about building up containers and stuff like that. These are from actual large enterprises that I've talked with or that are customers of ours. And the technical stuff is cool if you're a developer, right? It's fun to do things faster and better, and it's fun not to have to work on the weekend. But what I'm always interested in are really like the other results, right? How the organization actually improves, how you find actual business metrics that you're improving directly because of how you're now writing software, managing your infrastructure, and overall computering better. But just as a reminder, never minding all of that, I'm sure all of you here are in that 30 to 40% of people who have continuous integration in place. But there's that, let's see if I can do math. There's 60 to 70%, I think I got that right, who actually don't even have continuous integration in place, right? Who haven't tuned their whole delivery pipeline, their whole supply chain, right? They probably haven't done this analysis where they put, a fun thing to do is to think about what would it take us to deliver one line of code to production? And from me saying one line of code all the way to someone clicking on something that uses that one line of code, let's draw it all on the whiteboard, right? People often don't go through that process, let alone what would it take us to just redeploy what we already have with no modifications? So, I would make sure that you have a whiteboard somewhere, hopefully a picture of it, that shows that entire process and you've optimized it as much as possible, because that's the first step. So just by way of an introduction, that's me. If you come down to the Pivotal booth, you can get a couple of one of the books that I have out. I have a couple of podcasts that I do, and I tend to focus a lot more of my time on the business side of things and organizational change and product, if you will, which is a lot of what those two little booklets that I have are out. And there's inane stuff to listen to if you want. And then finally, as I mentioned, we have a booth downstairs. Pivotal was recently acquired by VMware, and our whole sort of deal, all the Pivotal stuff and the Kubernetes work that exists in VMware and some of the monitoring things is now under the brand of Tanzu, which is a fun name. And there's a lot of different ways, other than coming to the booth, that you can check in on that. Like I mentioned, we have a great Kube Academy online that you can go and walk through some courses and have people kind of help you learn about these things. We'll also be, as with many people, down in Amsterdam at QCon at the end of the month. There's a great day-long workshop if you want to get all into the nitty-gritty of Kubernetes that we're putting on that you can attend, plus the whole rest of the conference. And then finally, we do a lot of regional events that we call Spring One Tour. There's one in London, if you live here, coming up in June. We've also got one in the summer in Amsterdam and Paris and all over the world, definitely in the States and over in Asia. But if you're interested in this kind of stuff, you should come by the booth and check it out and get some free books. As I like to tell people, you should take all of them. I mean, one copy of each, because they're very easy to recycle if you don't end up liking them. And then I feel great because you took one of my books, and it makes me happy. So with that, thanks for coming, and I'll see everyone around.